Okay guys, welcome to this particular portion of our presentation where we're going to spend some more time talking about remedying this problem that we have based on the fact that RIP uses auto summarization and it's enabled by default. First, what I want to do is I want to illustrate that. So what we'll do is, let's pick a device. We'll come over here and just pick R1. And what I want to do is I'm going to do a show run and I'm going to say section router, and let's look at what our output says. Well, Terry, you said it was on by default. Router RIP version 2, here's our two network statements, nothing less, nothing more. Well, the issue here is yes, it is on by default, but not all default configuration, or let me rephrase that, default configuration is not going to automatically appear in our running config. Let's take a look at that, and I'll show you what I'm talking about. We have the capability of coming in and do a show run all. Now what I'm going to do is I'm going to say show run all, and I want to say begin with router RIP. Actually, BE, not NE. And let's go through and take a look at see what's going on. Well, let's see here. It started me where I didn't want it to, but let's go see if we can find, actually did it start me where I didn't want to start? 1 second here. No, it didn't. Notice right here it says version 2. Now there's additional configuration that we did not add. Notice it says validate update source, a configuration we're going to talk about here very shortly. Notice it gives me a listing of something referred to as my timers. Remember, we talked about the timers in our theoretical conversations with regard to how often our messages were going to be sent, what was going to happen when we waited a certain amount of time, what happens when we miss so many messages that are being sent by the system, and how our system is operating by default. Notice it also gives me information associated with my full mask. Notice I didn't enter 255.0.0.0, but it was assumed on the basis of the system, and it just entered it in directly. But when we do a show run, the mask space 255.0.0.0 doesn't appear. It's not relevant to us. Now the other part of here is notice it says maximum paths 4. In other words, this routing protocol is going to load balance or do equal cost multipathing across up to 4 equal cost paths. Also, notice it comes in and gives me my administrative distance, which is going to be 120. By default, we can change it, obviously, if we manipulate this term. And the thing is if I did go in here and change it, it would actually appear in the running config because it was no longer the default. Another element here that I wanted to drive home is it says auto summarization is on by default, even though I said I want to run version 2 so that I can communicate information about my variable length subnet masks. So looking at this, the other thing that I want to illustrate is what's going to happen when we come in and we do our config. And what I want to do here is I want to execute a debug. Now it's not often that I use debugs in live environments, excuse me, or even during the lab. I rarely ever, I could hardly ever think of an instance that I'd want to run a debug in the actual CCIE routing and switching lab. Now, I'm not saying the circumstances don't exist, and the reasons that I would run it would be few and far between, and there would only be a handful of them. But the main thing I want to drive home with this idea here is that while we're learning how these protocols operate in the context of these video on demands or any of the boot camps or your self-paced learning, what I want you to do is I want you to experiment with these debugs so that you can see things that are actually happening. Now what I'm going to do is I'm going to say debug IP RIP. And let's take a look and see if we can't use this to solidify some of the things that we talked about in the context of our theoretical discussions. Now we know the system is going to periodically begin sending messages, and these messages are going to be associated with prefixes. Keep in mind, each of these updates are going to be 512 bytes in size, and what we're going to find is that's going to give me enough information to be able to advertise about 25 prefixes. So if I'm running RIP and I had more than 25 prefixes, keep in mind it's going to take more than one update, RIP update, in order to be able to exchange all of the information between my devices. Notice I'm staying away from the word neighbors, because RIP does not do adjacencies. It doesn't work like EIGRP or OSPF. RIP merely just broadcasts the information out, and that's what I wanted to take a look at. So let's go through here. I'm going to take myself out of the equation so we can see the output, and I'm going to say you all and turn off my debug. Now what I want us to point out here is notice, first of all, it says here, I'm ignoring an update. I'm ignoring an update because it says it's coming from me. So I don't need to process that because I recognize the fact that it's coming from my own device. So it's sourced from one of our addresses, therefore I don't need to work with it. Now what I want to do is I want to look at my received updates here. So notice right here I have RIP received a version 2 update from 10.1.101.1, and notice it tells me information about this. It says it's the prefix 10.1.44.0/24, and it tells me it's 2 hops away. So when I also come in here and look at this, notice it's still only giving me information about 172.16.0.0/16, and that's what we need to talk about because we're not learning the more specific prefixes associated to our loopbacks. And again, this is wholly and completely part of this this auto summarization process that RIP runs by default. So let's disable that. Let's turn that off. So how do I do that? Well, what I'm going to do is I'm going to go to all of my devices and I'm going to go to the router RIP process. So config T, router RIP, and I'm going to say no, auto. Do show history. I'm going to grab that config. No, I'm not. I hate that. Go to 2, no auto. Go to 3, no auto. 4, no auto. 5, router RIP, no auto. Then we go to Cat 1 and Cat 2 and do the same thing. No auto and no auto. Now let's go up to 22 and make the final change, and that's where we're going to look at things. So config T, router RIP, no auto. Show IP route. Well, let's see. Let's look specifically at show IP route RIP and see what prefixes we have in here. Well, now notice we are learning the /24 prefixes. But the issue here is notice that we still have this 172.16.0.0/16 in my routing table. But what I want you to see here is notice that its timer is 55 seconds. So let's do this. Let's do a show IP protocols, and what I want to do is I want to look at RIP, and I want you to see here it's going to send updates every 30 seconds. So assuming that we don't miss any updates, that timer should never get higher than 30 seconds. Let's take a look at it again. So notice every one of these timers are arbitrarily low, less than 30 seconds. In fact, what we should see is these devices should actually reset when they get on, near, or around 30 seconds. Notice they went from .28 to .03. So that tells me that this information is being refreshed, but what is not being refreshed is this prefix right here. We're no longer receiving any information regarding the summary. But notice it's taking it several minutes for it to leave our table. And that's going to be, again, based on our theoretical discussions, part of this idea of our hold down and our flush. So we've entered hold down, and then what we're going to do is after 240 seconds, we're going to remove these from the table. Show IP route, RIP. Now, if I didn't want to wait that long, which I don't, what I can do is I can say clear IP route star and hit enter. And then when I do my show IP route RIP, what we're going to find here is that notice now my 16 is here, but it's not being learned as a /16. I'm learning about all of my individual /24 prefixes to include those that are even running on Cat 1 and Cat 2. So now if I repeated that ping to 10.1.45.5, I'm going to have reachability, and I'm going to even come up here and say trace route to 10.1.45.5, and we're going to see how it's actually going to travel. So there is no show IP route 10.1.45.5. There's now no notion of load sharing. The system has used the idea of hop count to be able to determine that serial 2/1 is going to be the way that I'm going to reach that particular prefix. And again, it's going to be based on hop count. Now, if I were to come in, config T, notice it's going to be a hop count of 3 here. if I went onto this interface and said config t interface serial 2/1 and I shut this interface down, do show IP route RIP, or let's see, route 410.1.172.16.5.5. Notice it's not in my routing table. But it's not in my routing table because RIP is just so slow to converge. Because remember, we have to rely on these hello messages that are going to be sent, excuse me, not hello messages, they're update messages that are going to be sent out all of the enabled interfaces. And what we want to do is we need to make certain that we wait ample time in order to be able to receive one of those so that we can actually repopulate the information that we just lost by bringing our interface down. We shut an interface down, which means the system automatically took the prefix that it used for reachability information out of our routing information base with regard to RIP. Now I've run my jaws long enough here. Let's see if we actually do show IP route. And now notice it's actually returned to our table, and notice its metric is 4. So we picked the lowest metric with regard to what particular piece of information we were going to include in our routing table. So I'm going to say no shut and turn that back up. Do show IP route RIP 10 or 172.16.5.5, and let's see what happens now. So it's not show IP route, or not show RIP, it's show IP route. So we're still going out 0. Let's see, no, this time we're going, yeah, it's still going out 0, 0. Debug IP routing. Let's see what happens. Now let's see, we should have received some information here. Notice we are updating information. Debug IP routing is a very handy tool. Now notice it's telling me the information that I'm updating, but let's see what happens if I wait a little bit longer. Notice here, we deleted this prefix and we added this prefix, and the only thing that changed was the fact that we learned it via 4 from serial 2.0 in this instance, and that updated our database. So now when I come up here and I say show IP route 172.16.5.5, I should be using serial 2.1. Let me U all this. Repeat that show command. We're using 2/1 to reach it because it's got a lower metric. So when we look at this from our drawing, what happened is that that prefix is being advertised to us from different sources. So right now, it's being advertised to us with regard to, it was going this way to here, which is going to be 1, 2, 3, 4 hops, or it's advertising being this way, which is going to be 1, 2, 3 hops. So again, keeping in mind that we're going to pick the lower metric, that's going to be the prefix that we're going to choose, or the particular route that we're going to choose to reach our destination of 172.16.5.5. Now, with all of that in mind, there's one other thing that I want to be able to illustrate here, again, just to drive home our theoretical conversations, and then we'll move into more fundamental aspects that we might use in order to be able to do RIP configurations like authentication, summarization, and things along those lines. Yes, I said summarization. We have auto summarization on by default, which is going to be happening everywhere, but there may be circumstances or situations whereby I want to do summarizations on specific prefixes, not on an entire or on the whole infrastructure, in order to be able to minimize the number of single stateful entries that I have in my routing table. So again, let's take a look at this last component here, and it's going to be debugging that I want to do again. So what I'm going to, let's see here, grab this. Let me grab my eraser and take that little dot off right there. That's going to bother me if I keep doing that. And what I'm going to do is I'm going to go to R1. I'm just arbitrarily picking a device. And what I'm going to do is I'm going to say, well, first of all, let's do this. Config T. Say access list 100. And what I want to do is I want to deny, actually, I don't want to deny. How do I want to do this? Because I want to see these updates. No, we'll just do a straight debug. Before I do that, config T, let's see, line VTY 0 to 1 or 0 to 4, and I'm going to say password IPExpert login exit, then I'll say enable password IPExpert. Just in case we run into a situation where we've got so much output that I'm going to get locked out, I want to be able to telnet into this device. So what I'm going to do now is say debug IP packet. And I'm going to say detail. And what we want to do is I'm going to go ahead and prepare my URL. What we're going to do is we're going to wait a little bit and see what happens here. Okay, URL this. Now why did I do this? Well, I did this because I want us to see the nature of the packets that we're sending between our RIP speakers. Now, we talked about the fact that we use UDP to be able to communicate with our RIP. And notice it says right here we're using UDP port 520 both for the source and the destination, and those are going to be the ports that we're using to send and receive our updates. Notice here I have an idea of the source. This came from 10.1.201.12, so it's coming from Cat2. I'm sorry, and yeah, it's Cat2 via interface 01. And notice here's that multicast address that we talked about in our terms of our basic operation. RIP uses UDP port 520, and it uses the multicast address of 224.0.0.9 in order to be able to exchange information when we're operating with IPv4. Keep in mind, RIP is a routing protocol that also supports IPv6, but it does so in what's referred to as RIP-NG, or the RIP Next Generation routing protocol that's optimized for the sole and express purpose of supporting IPv6. And we'll look at that, I promise. Other things that I wanted to look at here were going to be, let's see, PAC priority. So stop process PAC for us packet. Now what this says here is that any traffic that is going to be destined to or sourced from a device is going to be dealt with something referred to as PAK priority or PAC priority. All that simply means is that a packet that's destined to my device or sourced from my device is going to be process switched. Now, process switching versus our optimized or distributed switching like Ceph and other protocols like fast switching is going to be a way that we can actually be able to speed up the switching that takes place in our routing environment. Remember, we talked about the fact that routers switch and switches can actually route if they're layer 3 compliant. But the main thing that I want you guys to understand here is that it's going to be the nature of the packet that's going to determine whether or not we can see it with debugs. So if it's a transit packet, I can't do a debug unless I take my device and put it into a fashion whereby transit traffic is going to be process switched. Now, for the point of view of troubleshooting, that's going to be an awesome tool. But if you leave it in place, it's going to slow your routers down to a crawl, because you're basically turning off all the hardware optimizations in your infrastructure that you're going to need to ensure that you can send the information quickly, reliably, and successfully. So with that being said, we've walked through this idea of what our packets look like, what source and destination UDP ports are being used, 520. We talked about the multicast address of 224.0.0.9, which is a link local, non-routed multicast address that's used by RIP version 2 in order to be able to communicate its information. So with that being said, let's dive out of here and jump into another topic associated with more fundamental configurations specific to routing information protocol. See you guys in that video. Bye-bye.